So hi friends, in this lecture we'll discuss about the losses in pipes. So it means that in particular the minor losses, minor energy losses in a pipe. So already we have discussed about the different losses in pipes, major loss and minor losses. So major loss we have discussed, which will be due to head loss due to friction. So and we have derived the Darcy-Weisbach equation, and we have seen some problems based on Darcy-Weisbach and how to overcome these frictional losses, right? So next would be the minor energy losses. So minor energy losses will be due to sudden expansion of a pipe. So when there is a pipe, when it suddenly expands, right, of a larger diameter, from smaller diameter to larger diameter, we'll have some loss. So what will be the loss? So sudden contraction of a pipe. So from larger diameter to smaller diameter, when the pipe reduces, there will be some energy loss. So due to pipe bends, due to pipe fittings, and due to some obstruction in sense of pipe fittings and obstruction, so what will be the energy loss, we're gonna discuss in detail. So minor losses, so as we know, major loss will be due to friction. So minor losses, first one will be due to sudden enlargement. So it is due to sudden enlargement of a pipe. It is denoted by HE. So H is a head, E is a expansion. So head loss due to sudden expansion is given by the formula V1 minus V to the whole square by 2G. So we have a derivation for this. You can go through your textbook. So if you have doubts, we can clarify them in later on. Okay, so this was a pipe. So from a smaller diameter pipe, when suddenly it expands to a larger diameter of pipe, so there will be some loss in energy. So that will be calculated based on this. So V1 will be the velocity in pipe 1, V2 will be the velocity in pipe 2 divided by 2G. So next, sudden loss due to, loss due to sudden contraction. So here we have a larger pipe. So from larger pipe it suddenly contracts. Okay, so it is a sudden contraction of pipe denoted by HC, so head loss due to sudden contraction, which is equal to 1 by CC minus 1 whole square. CC is the coefficient of contraction, so which actually varies from 0.6, I think so probably this, if you simplify this would be around 0.36 into V square by 2G. So we assume that to the near term, if coefficient of contraction is not given, so we take the formula 0.5 V square by 2G. So HC will be equal to 0.5 V square by 2G. So then head loss due to exit of a pipe. So we have a pipe, right? So from a pipe connection, the fluid has to come out. So when it exits, what will be the head loss? So head loss will be equal to, exit of pipe will be equal to V square by 2G, which is a kinetic head. So generally it's a kinetic head. So next one, so due to pipe fittings, so we'll have certain pipe fittings. So due to these pipe fittings, there will be some energy losses. So energy losses will be, HP will be equal to K into V square by 2G. K is a pipe fitting the coefficient. Okay, so that we have a table for each pipe fittings. We can, the coefficient actually varies. So loss at entrance, which is mean like inlet of a pipe. So from a tank, the water has to get into the pipe. So we think of an overhead tank. From overhead tank, we have a pipe connected to the household, the household pipes, right? So maybe the wash basins or to the bathrooms, right? So when it's been connected at inlet of a pipe, so from the tank, when water enters to the pipe, so there will be some energy losses. So that will be nearly the same of head loss due to sudden contraction. So that's why HI or entrance, so HE, so will be equal to 0.5 V square by 2G. So these are few. So this is being derived based on the Bernoulli's equation. From then we can able to find these values, this equation. So hope you guys have got some the idea about minor losses in a fluid flow. So we'll discuss a problem, then you will have able to understand much more clearly. Thank you guys.